Engines lesson. In this lesson, you will learn about the aircraft's two engines and their respective components and controls. In addition, we will review both normal and non-normal engine indications. The airplane is powered by two Rolls-Royce Trent 1000K engines. The engines are each rated at 73,800 pounds of takeoff thrust. The engine is a three-rotor axial-flow high-bypass turbofan engine. The rotors are designated N1, N2, and N3. The N1 rotor consists of the following items on a common shaft: a fan and a low-pressure turbine section. The N2 rotor consists of the following items on a common shaft: an intermediate pressure compressor section and an intermediate pressure turbine section. And the N3 rotor includes a high-pressure compressor and a high-pressure turbine. All three rotor assemblies are mechanically independent from each other. An engine accessory gearbox is driven by the N2 rotor. Each engine is controlled by an electronic engine control, or EEC. The EECs monitor autothrottle and flight crew inputs through the thrust levers to automatically control the engines. Engine controls are located throughout the flight deck. Review the engine controls before pressing the Continue button to resume the lesson. Primary and secondary engine indications are provided on the EICAS display. The EICAS is normally displayed on the inboard MFD window of the captain's or first officer's inboard display unit. The EICAS display can be swapped between the captain or first officer inboard display unit by selecting the EICAS transfer switch on either display select panel. Engine indications can be presented as digital readouts, round dials with moving pointers, or vertical indications with moving pointers. The digital readouts display numerical values, while the moving pointers indicate relative value. If engine data is not available, the associated engine indication blanks. There is no EICAS message relating to the loss of engine data. The normal operating range on a dial or vertical scale is displayed in white. The oil temperature, oil pressure, and EGT indications have caution ranges displayed by amber bands. Operation in the amber band will change the color display of that indication. For example, if oil temperature reaches the caution range, the digital readout box, and pointer change color to amber. The indication changes color back to white when it returns to the normal operating range. N1, N2, EGT, oil pressure, and oil temperature indications have operating limits, indicated by red lines. If one of these indications reaches the red line, the digital readout, dial, box, and pointer change color to red. The N3 indication does not have a range or red line limit, but will change to red if the operating limit has been reached. The oil temperature and oil pressure indications change color back to white when they return to the normal operating range. When N1, N2, N3, and EGT return to the normal range, the indications return to white, but the box remains red as a reminder of the exceedance. The red box color can be canceled or recalled by pressing the Cancel Recall switch on the DSP. The primary engine indications are always present on the ICAS display. The primary engine indications are TPR, N1, and EGT. The turbofan power ratio, or TPR gauge, is the primary thrust reference indication. The following items are displayed on the TPR indications: maximum TPR amber line, reference target TPR, commanded TPR sector, reference TPR, actual TPR, and actual TPR indication. Review the TPR indications before pressing the Continue button to resume the lesson. The N1 indications include the following: N1 red line, N1, and N1 indication. Review the N1 indications before pressing the Continue button to resume the lesson. The following items are displayed on the EGT indications: EGT red line, EGT amber band, EGT indication, EGT start limit line, and EGT. Review the EGT indications before pressing the Continue button to resume the lesson. Secondary engine indications are displayed on ICAS below the primary engine indications. The secondary engine indications can be displayed by pushing either secondary engine display switch on the Display Select panel. The secondary engine indications are N2, N3, fuel flow, oil pressure, oil temperature, oil quantity, and engine vibration. The secondary engine indications are automatically displayed when the displays initially receive electrical power, a fuel control switch is moved to cutoff in flight, an engine fire switch is pulled in flight, a secondary engine parameter is exceeded, engine N2 RPM is below idle in flight, a start selector is in the start position, or the fuel flow engine left or right advisory is shown. When secondary engine parameters are automatically displayed on ICAS due to any of the above conditions, they cannot be cleared until the condition is no longer present. After the condition is resolved, the secondary engine parameters can be cleared by pushing the engine display switch. The N2 indications include the following: N2, N2 redline, N2 indication, running indication, starting mode, and idle target indication. Review the N2 indications before pressing the Continue button to resume the lesson. The N3 indications are shown as a simple digital readout. This display will change to red if the operating limit is reached. Review the N3 indications before pressing the Continue button to resume the lesson. The fuel flow indications are digital readouts only. Review the fuel flow indications before pressing the Continue button to resume the lesson. Oil pressure and temperature indications are a combination of digital readouts and vertical indications with moving pointers. The following items are displayed on the oil pressure indications: oil pressure amber band, oil pressure pointer, and oil pressure red line. Review the oil pressure indications before pressing the Continue button to resume the lesson. The following items are displayed on the oil temperature gauge: oil temperature red line, oil temperature amber band, and oil temperature pointer. Review the oil temperature indications before pressing the Continue button to resume the lesson. The oil quantity in liters is shown as a digital value only. Review the oil quantity indications before pressing the Continue button to resume the lesson. Engine vibration indications are a combination of digital readouts and vertical indications with moving pointers. The following items are displayed on the engine vibration indications: engine vibration source, engine vibration pointer, and engine vibration high band. Review the engine vibration indications before pressing the Continue button to resume the lesson. Each electronic engine control has full authority over its respective engine operation. The EEC uses thrust lever inputs to automatically control forward and reverse thrust. The EEC has two control modes: normal and alternate. In the normal mode, the EEC uses TPR as the parameter for setting thrust. In alternate, N1 RPM is the thrust reference parameter. During normal operations, the EEC is powered by a dedicated permanent magnetic alternator, or PMA. For engine start, initial EEC power is supplied by the airplane electrical system. The airplane also serves as an alternate EEC power source whenever a PMA is unavailable. In the normal mode, the EEC sets thrust by controlling TPR based on thrust lever position. TPR is commanded by positioning the thrust levers either automatically with the autothrottles or manually by the flight crew. The EEC also continuously computes a maximum TPR value. Maximum TPR represents the maximum rated thrust available from the engine based on air temperature and pressure altitude. Maximum rated thrust is available in any phase of flight by manually moving the thrust levers to the full forward positions. If the required signals are not available to operate in the normal mode, the EEC automatically switches to the alternate mode. In the alternate mode, the EEC schedules N1 as a function of thrust lever position. No thrust protection is available in the alternate mode. When the EEC initially switches an engine to the alternate mode, and the associated mode switch is in normal, the EEC enters the soft alternate mode. In soft alternate, the EEC uses a snapshot of the last known ambient conditions to calculate maximum N1 data. In this mode, the TPR indication blanks and the N1 display remains the same. On the mode switch, both normal and alternate will be illuminated. When the EEC mode switch is pushed, the normal light extinguishes and the engine switches to the hard alternate mode. In hard alternate, the EEC sets thrust using N1 and an alternate pre-programmed thrust schedule. The N1 indication changes to include reference and target N1, maximum N1, and commanded N1. The engine EEC mode left or right advisory message illuminates anytime the engine is in an alternate mode. When operating in soft or hard alternate mode, the autothrottles will remain connected. If only one engine has changed to alternate mode, selecting the alternate mode on the other engine will eliminate thrust lever stagger or asymmetric thrust. The alternate mode thrust schedule provides equal or greater thrust than the normal mode for the same thrust lever position. Since thrust protection is not provided in the alternate mode, maximum rated thrust is reached at a thrust lever position less than full forward. As a result, thrust overboost can occur at full forward thrust lever positions. Advancing the thrust levers to full forward while in alternate mode should only be considered during emergency situations when all other available actions have been taken and terrain contact is imminent. The ICAS caution message, engine limit protection left or right, is displayed if the thrust lever position commands an N1 greater than the maximum rated thrust or maximum N1. The EEC monitors N1, N2, and N3 rotor speed to provide overspeed protection. If N1 or N2 rotor speeds approach the red line limit, the EEC commands a reduced fuel flow. When RPM limiting is in effect, the ICAS advisory message, engine RPM limited left or right, is displayed. If the red line limit is exceeded, the ICAS caution message, engine limit exceed left or right, is displayed. If RPM limiting fails and an overspeed condition persists, the EEC commands fuel shutoff to shut down the engine. Once the engine falls below idle speed after shutdown is commanded, the ICAS caution message, engine fail left or right, is displayed, and an aural beeper sounds. Each engine includes a secondary air system, or SAS, that provides cooling and sealing airflow to the intermediate pressure turbine. Air for this system is provided by intermediate pressure air from stage 8 and high pressure air from stage 3. A secondary air system valve, or SASV, regulates the air from these two stages. System control and monitoring is automatically provided by the associated EEC. If the SASV fails in the closed position and the engine is at idle speed, the EEC automatically commands a higher engine idle speed. This prevents ingestion of turbine annulus gases into the SAS system. When on the ground and below 80 knots, this is indicated by the engine control left or right ICAS advisory message. Failure of the SASV in the open position could lead to an abnormally high temperature in the system and overheating of the engine bearings. If the valve fails open, the maximum thrust indication is reduced on the TPR. If this occurs above 400 feet AGL, thrust is automatically reduced to a safe limit and the thrust command arc on the TPR gauge displays amber. Additionally, failure of the SASV in the open position will be indicated by the following: ICAS warning message, engine thrust high, left or right, displays with siren, and/or the ICAS advisory message, engine secondary air valve, left or right, displays. Thrust control malfunction accommodation is an EEC function that provides protection against idle thrust asymmetry conditions while on the ground. The EEC commands shutdown of the affected engine when the airplane is on the ground, the thrust lever is at idle, and the engine is above idle speed and not decelerating normally. This results in an associated engine fail caution and an oral beeper. Thrust asymmetry protection, or TAP, is an automatic feature that provides protection against asymmetric thrust during takeoff or go-around by limiting thrust on the higher thrust engine. TAP enhances safety by allowing a decrease in approach speed at light gross weights, providing engine-out control capability for speeds above stick shaker, and allowing full rated thrust to be available for all engine operation at all weights and airspeeds. For an engine-out condition, TAP reduces thrust on the operating engine to ensure there is sufficient rudder for directional control. TAP reduces thrust when the airspeed decreases below approximately V2 on a takeoff, or below approximately VREF on a go-around. Once speed is increased above V2 or VREF, TAP increases thrust. The TAP function does not affect thrust for engine-out operations flown at or above V2 or VREF, with the exception of a lightweight go-around at less than 152,273 kilograms, where TAP reduces thrust slightly at VREF on the go-around. In the following example, the right engine has failed and TAP is actively reducing thrust on the left engine. As TAP reduces thrust, the maximum and commanded TPR ticks move down to the reduced TAP thrust value, and the actual TPR indication follows. The reference target TPR indication and the thrust levers do not move. As TAP increases thrust back to normal, the maximum and commanded TPR ticks on the left engine move up until they again match the reference target TPR indication. TAP does not affect certified takeoff performance. For airspeeds where TAP does limit thrust, climb gradient is higher with TAP limiting thrust than it would be if TAP did not limit thrust. This occurs because additional thrust asymmetry creates more airplane drag than the thrust that was added. Therefore, if TAP becomes active due to a speed reduction below V2, any reduction in climb gradient from that scheduled for the takeoff is due to mismanaged speed and not due to TAP. TAP is only available when the flight controls are operating in normal mode, and the EEC is in normal or alternate modes. If the TAP function is inoperative, the ICAS advisory message Thrust Asymmetry Protection is displayed. The EEC will automatically command different idle power settings depending on certain conditions. Possible idle settings include minimum idle, approach idle, icing idle, and ice crystal idle. Minimum idle. Minimum idle is selected for ground operation and most phases of flight. Approach idle. Approach idle has a higher thrust than minimum idle. This decreases acceleration time for go-around. Approach idle is selected in flight when the flaps are commanded to 25 or greater, and the landing gear is selected down. Approach idle is maintained until after touchdown when the EEC selects minimum idle. Icing idle. Icing idle is selected when engine anti-ice is on and is approximately the same setting as approach idle. Ice crystal idle. Ice crystal idle is selected in flight when outside air temperature is between ISA and ISA plus 29 degrees Celsius, or altitude is between 35,000 and 5,000 feet.